Okay, welcome. This is the solution to the problem of the day that was posted this morning, 8:10. Okay, so part A, we said find dx, dy, dz using the multivariable chain rule. And I know you know how to do this, right? So x over u du, x over v dv, yu du, yv dv, zu du, zv dv. Okay, I know you know how to do that, but we had to do it. Now, part B, this is the interesting part. Use the three equations you just found, dx, dy, dz. Find the wedge products that go into our 2 form, which are these. So you want to take these and wedge them together in the order you found from video 1. Okay? So let's do this one first. Dx wedge dy. So here's dx wedge, here's dy. Now you know that anything wedged with itself is 0, so du wedge du is 0. I should say any vector wedged with itself is 0. Du wedge du is 0. Dv wedge dv is 0. Okay? So that means we only get du wedge dv. So it'll be x over u times y over v, du wedge dv, and we would get x over v times y over u, dv wedge du. Now we can flip these, right, and factor out a du wedge dv, and we get this expression. Because when I flip it, right, this makes this a negative. Now, do you recognize this? Do you recognize this? That's the Jacobian. Look at that. Remember this? X, X, U, V, Y, Y, U, V. You take the determinant, this times that minus this times that, and you get exactly what we had. So that makes doing these so much easier, right? So now let's do dy wedge dz, but let's use the Jacobian, all right? So you look at what's first here, dy. So you go y, y, u, v. What's next? dz. You go z, z, u, v. Take the determinant, this times that minus this times that, and you get the right answer, du wedge dv. Got one more. dz wedge dx, all right? Z is first, Z, Z, U, V. X is next, X, X, U, V. Take the determinant, this times that minus this times that. And here it is, du wedge dv. And that's it. All right. So we've got now what we need to do our integration on this Riemannian manifold, which is next. All right. I'll see you tomorrow.